Hello and welcome to another edition of Medical Technology Today. I'm your host, Eddie Deal. I'm the Intellectual Property Marketing Manager for the Office of Technology Development at the Medical College of Wisconsin. And I am joined today by Dr. Balaraman Kalyanaraman. He is the Harry R. and Angeline E. Quadracci Professor in Parkinson's Research, and he's also Professor and Chair of Biophysics here at the Medical College of Wisconsin. Raman has an exciting technology that he'd like to talk to you about today, and specifically it's in Parkinson's disease. Raman, thank you for coming today. Can you tell us a little bit about Parkinson's disease? Obviously this is a terrible disease.
Yes. This is a chronic debilitating diseases, and this occurs with aging, and sometimes it also occurs in younger people. It involves selective destruction of neuronal cells. So it happens in a place called substantia nigra in the brain, and this part of the brain produces dopamine, which is important for cell-cell communication. It's called a neurotransmitter. So Parkinson's disease involves selective destruction of dopamine-producing cells. So we need to develop drugs that protects neurons by preventing them destroying them, and by which they can keep producing more dopamine.
Okay. And you have a small molecule drug
Yes.
that you've developed
Yes.
that can actually protect cells against this neurodegeneration.
Yes, it is so far we do not have any drugs that can delay or prevent this disease. And what we have here is a unique mitochondria targeted molecule, and mitochondria is important for cells. It makes energy, and it's also now considered to be a signaling molecule. So this is a uniquely druggable target, and our technology involves making molecules such that they can be transported into mitochondria without causing toxicity to cells. This involves combining a triphenylphosphonium group to a naturally occurring molecule such as vitamin E or aposinin through a linker chain whose length can be changed. By this mechanism, we can selectively target the inner mitochondrial membranes, and also this can be concentrating in a place where people think that there is a dysfunction. And the beautiful thing about this technology is that these molecules are taken up into mitochondria and cause changes in the energy sensing mechanisms of this organelle. And by this, these molecules can make the cells conserve energy. So in neuronal diseases, we need to conserve energy in the cell, and some of these molecules will make the cells use up the energy and act as a neuroprotective agents.
It's very interesting. So you've created a molecule that it's orally available. I understand that you would be able to take a pill.
It will be orally available.
And it goes right to the part of the brain that's affected by Parkinson's. It goes into those cells, goes into the mitochondria within those cells,
Yes.
and that's where all the action takes place.
Yes, and so although some of these similar technology was developed in other labs, and we think the mechanism by which now they're acting as neuroprotective agents is different. They are not acting as a traditional free radical scavengers and all that. They are actually operating by a uniquely different mechanism.
Okay.
By looking at the bioenergetics of the cell and also by altering the bioenergetic utilization of the cell.
Because people always talk about free energy or free radical scavengers,
Yes,
and there are many things on the market and
Yes.
many people working in those areas. But this is different.
This is we have tested this molecule. For example, we have a molecule called epocyanin. We have tested these molecules in neuronal cells, and we have also tested this efficacy of this molecule in a variety of animal models of Parkinson's disease. And there are we have almost used most of the animal models that are now presently available to test drugs for Parkinson's disease, and in all of these animal models, our molecule is acting as a neuroprotective agent.
That's great. Well, this is a poorly understood disease, but we're understanding more all the time because of work coming out of labs like Dr. Kalyanaraman's. So thank you for coming in today. I know you're busy. You want to get back to work. Appreciate your time, and we'll see you again in another episode in the future.
Thank you.
Thank you very much for coming in.
Thank you.